I'm going to demonstrate for you what you're trying to accomplish in this lab. First thing we want to do is open up Factory I/O. Once you've opened it, you want to open a particular scene, so hit Scenes. And there's the standard scenes that come with Factory I/O, and then there are the custom scenes that I've been working on. Click on My Scenes to see the custom scenes. They're all on the instructor station. And then click on Convergence Station. What I want you to do in this lab is to make it so that when you press the start button, the conveyor starts and moves the item along the conveyor and doesn't stop when you release the button. And then finally I want you to use the stop button to stop it. And then there's another challenge in the lab for you to use this other button, which is actually labeled reset, but use it as a jog button so that when you hold it down the conveyor goes, but when you let it go the conveyor stops. I'm not going to show you the solution to all of that, but I do want you to understand how Factory I/O works and how it talks to the PLC. So let's also start the Click programming software, not the project, but the programming software. I'm going to say start a new project, and I could select the PLC, but it shouldn't make any difference. I'll just say OK. So I'm just going to make a small demonstration program so you can see how Factory I/O talks to the PLC. We'll bring in a set of contacts, and we need this to represent the input push button. And you would think that the inputs would be on the X's. Unfortunately, Factory I/O has no way that I've found to force input addresses on. So instead we'll have to use control relay addresses. And I'll go to C1. Now if we go over into Factory I/O and go to drivers, you'll notice that the start, reset, and stop button, as well as emergency stop and many other things, are already connected as inputs. But the question becomes, what address do I use in the PLC? Well, you'll notice that the first address for the at entry 1 sensor is 16384. In the PLC software, the Click programming software, if you hit display Modbus addresses, you'll see that 16385 is the lowest address for the memory spots. Now there's a 1 unit offset between the actual address in the Click and the actual address in Factory I/O. So address 16385 in the Click is address 16384 in Factory I/O. I think it has to do with the fact that Click always starts counting at 1 instead of 0, but that doesn't matter. What matters is we want to grab the start button. That's at address 16389 in Factory I/O, so that would be 16390 in the Click. So I'll click on that address. I'm going to edit it so that I can name it Start Button. There we go. Go back to pickup mode, we'll select that address, hit OK, and now address C6 is Modbus address 16389 in Factory I/O and 16390 in the Click PLC. So now whenever in Factory I/O, once I'm running the simulation, if I press that start button, that should make this particular memory address in the physical PLC turn on. And what I'd like to have happen is I'd like to have that drive the conveyor. Now if we notice, there's conveyor 1 on address 8192, conveyor 2 on 8197, and then the exit conveyor is 8202. Let's start with conveyor 1, 8192. So the address is 8192 here in Factory I/O. That means it's 8193. Now you don't type 8193 here in the Click. Instead, go in and look at the Modbus addresses for the outputs. We're in the Y sections, all the outputs, and you'll notice it begins at 8193. So that's 8192 over in Factory I/O. So I'm going to edit this one and call it conveyor 1. Go back to pickup mode, grab it, OK, and there's our address. So when I hold down the start button, that should make the conveyor come on, but that's not what I want you to do in this lab. I want you to press the start button, release it, and the conveyor keep going. You'll have to use a seal-in circuit to do that, and then you'll have to figure out how to make the reset button operate as a jog button. So now I should be able to write this into the PLC, but it doesn't have the PLC's configuration yet. Except I forgot one thing. I need an end instruction. There we are. So if I choose to write the project into the PLC, then I remember I haven't connected to the PLC yet. That's okay. I'll hit connect. It'll say there are differences between the system configuration in the PLC and in the PC. So it notes that in the PC I've got a CPU, that's this one. In the PLC I've got a different CPU. I've got no I/O module in the PC, in other words the programming software, but there are I/O modules. My choice is to either yes, use the system configuration in the PLC, or no, use the system configuration in the PC. The PC doesn't know. In other words, the Click programming software has just gone out and said hi to the PLC, and the PLC has said, I'm configured differently than you think. Okay, so I want to use what the PLC has. So what I'm going to do is say yes, use what's in the PLC. Now I have to name it. I'll just name it something temporary. It's fine. And then hit OK to upload the program to the PLC. It's in run mode. Let's change to stop. Yes. Transfer is complete. Change it to run mode. There we are. And we are monitoring it. So now the other thing to do, notice the Click programming software was talking to the PLC to program it. Factory I/O is not yet actually connected to the PLC. It's not talking to it yet. We need to establish a Modbus connection over Ethernet. So in this configuration, this driver configuration, you have to hit connect. Now once you get that green check mark, the Factory I/O software is talking to the PLC. It's letting the PLC control its conveyor, for example, and it's sending information to the PLC, to that memory address that represents the start button. So let's go and let's start the simulation. And if I hold down the start button, conveyor 1 should move. Let's find out if that works. Sure enough, conveyor 1 does move. When I let go, conveyor 1 stops. Now that's nice. Let's keep playing with it. Let's see what happens here. So I'm holding down the start button, and we get to these transfer conveyors, and they're not really doing anything. So it looks like we've got kind of a pile up here. It'd be nice if the other conveyors would operate at the same time. Now if I turn on conveyor 2, that'll just make more of a traffic jam. So just for the sake of this, since our focus is on sealing in the start and stop buttons, I'm going to make conveyor 1 and the exit conveyor work. Now if you go back and look at the addresses, the exit conveyor is all the way down here at 8202. Now in Click that's going to be 8203. So let's go back to the Click software, and I'm going to do something here. I am going to grab another output. Let's see, I think I can put it here. And I've got to decide on the address. Remember, it's 8202 in Factory I/O. I want 8203 in Click. So let's have a look at the Modbus addresses. And 8203 is down here. It's Y011. I'm going to edit that. Y011. We'll call this the exit conveyor. Back to pickup mode. Select the right address. Hit OK. There we are. Now I think what I can do is connect both of these, because when one conveyor runs I want the other one to run as well. This is just instructions on how to use the wiring tool. So I'm going to go, let's see, like that. That should be fine. It looks like what I'll need to do is move this one up, but I can't drag and drop, so I'll just drag one right there. I know that it's Y11. It's already used. That's okay. I'm going to delete it. So get rid of that. And now I've got a branch here. So what happens is whenever the start button is pressed, both conveyor 1 and the exit conveyor should come on at the same time. Let me put my end statement back in there. And now let's write this program to the PLC. We are in run mode. We hit OK. We'll switch to stop mode. That's fine. Project's written. Transfer is complete. Go back to run mode. So now back in Factory I/O, when I press the start button, now both the exit conveyor here and the conveyor 1 entrance conveyor should run. There we go. So you can see the exit conveyor running. The only thing that's slowing me down is that transfer right and transfer left conveyor. I'm not exactly sure how to use those because they're supposed to be able to move things left and right. Why don't we figure it out? Let's go see what outputs are available for those transfer conveyors, because I'd just like to make this one long conveyor. And obviously I want you to set it up so that when you hit the start button you can release it and it'll just keep going, and then you can hit the stop button and it'll stop. But let's try to make it even better. What do we have for our it looks like we have, let's see, load 1, unload 1, transfer right, transfer left, and this is conveyor 1. Then we have conveyor 2, load 2, unload 2, transfer right, transfer left, and then our exit conveyor. So this is set up where we've got two conveyors side by side that are mirror images of each other. Obviously conveyor 1 is the big conveyor, but I don't know what load and unload are. Transfer right, transfer left. I don't think I want to transfer items to the right or left laterally, so I think that those are not what I want to use. It's either load or unload. Let's try load. That would just be the address immediately after. So let's reset our simulation. And let's see, let's go to Click Programming Software and let's add another branch. Bring it over here and connect an output. And remember that the load 1 was immediately after the conveyor 1 address, so it must be Y002. You can verify that with the Modbus address. So now let's upload this to the PLC and see if this makes things work a little smoother. Transfer is complete. We'll go to run mode, and we're running over here. So I'm holding down the button, and things are much better. So load 1 must be making that small section of conveyor that has the orange in it, the orange color between the rollers, must be making it move forward. I suppose unload would make it go backward. Just for fun, let's give it a shot and see what happens. So we'll reset the simulation, and if we look on the drivers, unload is going to be after. So we've got 8192, 8193, which is Y002. This must be 8194, Y001, or over on the click it would be Modbus address 8195. But it's Y00, let's see, 3. So that's fine. So we'll just for fun, we'll make this Y003. And I realize I should have named these. Probably just match whatever's already there. Let's see, conveyor 1's already named. Y002, oops, I selected it. Let's go to edit mode. Y002 was load 1, and Y003 was unload 1. Go to pickup mode. I'm going to try to make it go backwards for fun. Let's just see what happens. So Y003, download that. I mean, after all, we're engineers. Once things work, we have to know how good they are and what it takes to break them, right? So let's try to break this and see what happens. Transfer is complete. Go to run mode. Let's go back, and we're in run mode in the PLC. We're simulating in Factory I/O. So let's hit the start button. And I hope those conveyor rollers are running backward. This should just stop and kind of bounce back and forth. There we are. Perfect. If I hold down the start button long enough, will it give me another pallet to run into this? Yes, it does. So we're really fighting that intermediate small section of conveyor, but it looks like the big conveyor is able to overcome it. And once we get another one, maybe that will push the first pallet through. Nope, not enough force. How about another pallet? Yeah, there we go. And so now the last conveyor takes over. So it's much better, obviously, to run the load direction of that small intermediate section of the transfer conveyor, but just for fun I did it this way. So what I want your system to do is to just run through smoothly when you press the start button, and when you release it, it should continue running. You should have to press the stop button to make it stop, and then the reset button I want you to add on to your program and make it turn the conveyor on temporarily so you could just position a pallet without having to try and move it manually. But as soon as you release the reset button, it should just shut off.